Our first talk will be by Jadey Ryan, using Shiny to optimize the climate benefits of a statewide agricultural grant program. Thank you so much.
I am so excited and nervous to be up in front of you all, but I am going to start with a little background of how I came to R. So I would consider myself a self-taught intermediate R user. In 2019, I graduated with degrees in biology and environmental studies. Sorry. And I got hired by the Washington State Department of Agriculture to scoop water to test for pesticides. So water quality work, no programming, no computer science background, but I've always had obsessive tendencies to optimize and increase efficiency and make things very beautifully formatted. And this led to me applying for this opening in my work group for a data scientist role. So again, no background in computer science. I ended up just teaching myself some basic R data wrangling and visualization. I used David Key's parameterized reporting tutorials and passed my skills test. So I got the job. And I definitely suffer with imposter syndrome and feeling like I'm not really a data scientist. That's my title, but I focus mostly on automating things and creating useful and beautiful data products and decision support tools. So one of these decision support tools is this Shiny app for a statewide agricultural grant program called the Sustainable Farms and Fields. And this program provides grants to incentivize climate smart practices. What I mean by climate smart practices are things that can sequester carbon and reduce greenhouse gas emissions. An example of a practice is reducing tillage. And the photo in the background of this slide is a no-till drill that we purchased in fiscal year 2023 for the San Juan Island Conservation District. And last week, actually, we awarded another $1.5 million for fiscal year 2024. So this grant program has potential for really high impact. And this meant that it's really important for us to be able to estimate climate benefits from these practices that we're funding. And this is really challenging, especially in Washington State, because these benefits depend on so many different factors, like soils. For example, in this picture, you can see the soils vary in texture and color. Other factors that influence the benefits can be climate, cropping systems, geology. So this means that we need a decision support tool that can accurately identify the projects that have the greatest climate benefits. There are a couple of tools that are already available, created by the US Department of Agriculture and Colorado State University. And the first is Comet Farm, and it can be used for on-farm carbon and greenhouse gas inventorying and accounting. But it is a robust model that requires a lot of data input. So you actually every user has to enter in 20 years of baseline historical management data. So it's too hard to use. It's not practical for the statewide program. Then on the other side of the spectrum, we have Comet Planner, which is too simple. It doesn't allow us to compare practices across counties. It doesn't allow us to visualize the estimates, and it doesn't it doesn't help the user interpret what those estimates mean. This led us to creating our own decision support tool called the Washington Climate Smart Estimator. And our wish list for this new tool is that it absolutely had to be user-friendly for grant applicants and the general public. So we can't have people spending hours inputting 20 years of management data. We wanted to allow users to interactively visualize and compare across different conservation practices and plots and tables. We wanted to convert these CO2 equivalent estimates that are in metric tons per year into familiar terms so that people could actually understand what these estimates meant. And lastly, but perhaps most importantly, is we needed the results to be in a downloadable format. So the users could download spreadsheets and reports and then submit them as part of their grant applications. So I'm gonna go through a really fast 3-minute demo of some of the features of WaCSE. So this is the splash screen. When you first load the app, it describes what WaCSE is, what you can do with it, that we have these help buttons for additional guidance, and a reminder that the data are not saved on the website, so you have to download them. We have definitions for what is a carbon dioxide equivalent, what are greenhouse gases. We have these help buttons that give you pop-ups that can guide you through the different inputs and outputs. And we're going straight to the Calculate Your Estimate tab for time's sake. And we're gonna add a conservation practice in Adams County, which is in Eastern Washington. We're gonna add cover crop in a non-irrigated system, specifically legume seasonal cover crop. And we're gonna put this on 500 acres. Now this is an interactive DT data table. We're gonna compare that Adams cover crop practice with a Western Washington practice, a practice implemented in Western Washington, King County, where we all are right now. And you can see that Adams has the higher impact of like 54 versus 44. It's a really simple calculation. It's just the acres times the emission reduction coefficient. And we can download our data into a spreadsheet. And people can use this for either additional analyses, or they can submit this as part of their grant application. We have an interactive plot using the gggraph package. And then we can scroll down to the summarize and download section. And this is where we can see the entire project. So we have 1,000 acres. We have 98 total metric CO2 equivalents per year. And we can now download our report. So what's happening in the background is a parameterized R markdown is rendering a PDF report. And this report is meant to be a standalone, something that you can hand to somebody. It contains the background behind WaCSE, the definitions you need to understand and the tables, the plot, and this information and context to understand your impact through these equivalencies. So now going to the Understand Your Impact tab. This is using the Environmental Protection Agency's greenhouse gases equivalencies calculator. And we are entering our 98 metric tons per year. And now we can see in familiar terms that 98 metric tons is equivalent to greenhouse gas emissions avoided by, say, about 34 tons of waste recycled instead of landfilled. So that is much easier and in familiar terms for somebody to understand, as opposed to just, I saved 98 metric tons of CO2 equivalents. Okay, so I am a new R user when I built this. And my first step, of course, was to learn Shiny. So I started with examples, and I used the Shiny gallery as a, to just browse through what's possible with Shiny. And the gallery is really cool because you can see the source code and the output from that source code. And then I really thoroughly read the first few chapters of Mastering Shiny and Engineering Production Grade Shiny apps, which are really important for getting the overall workflow of building a Shiny app. And then I read through the rest of the chapters and sort of bookmarked in my head like what these chapters contain so that I could reference them later as I got stuck. And before I even started coding, I first sketched out my data flow. So what were my inputs? What are my reactive expressions? What are my outputs? And then sort of drawing out what I wanted for the user interface. And it doesn't exactly look like what my app is now, but this helped me avoid going down a lot of different rabbit holes so that I was able to just focus on the big picture of what I wanted for the data flows and the overall feel of the app. So once I had this big picture idea, I was able to start constructing the code. And I first just prototyped everything by building out the tables and the plots before introducing Shiny. And another example is these help buttons that are all throughout the app. So I created one, tested it, made sure that it worked like I needed it to. And then I refactored and extracted a custom function for these elements. So similar to Deepsha's talk with Shiny modules, refactoring into modules and with custom functions. And then the fun part for me was elevating the user experience. And this was done by incorporating HTML and CSS, which helped me to improve the look and the feel of my app. A really good package is VSLib for Shiny. And then JavaScript was used to improve more of the functionality of the app. So for example, default Shiny behavior, it just disconnects the user after X minutes, and it gives you the lower left little dialogue that says disconnected from the server. You can't customize that. It's pretty bland and boring. And again, the user doesn't get any warning. So instead, I can use the Shiny JS and Shiny disconnect packages to add a warning box that comes up that says, hey, your session is going to time out in 3 minutes, because I have my the pop-up comes up at 3 minutes, at 7 minutes, and it says your app will time out in 3 minutes. And then when it eventually does time out, it will give you this nice pretty message that comes up in the center of your screen rather than the tiny one on the lower left. So if you take no shiny things from my talk, I hope that I can be sort of a case study for trying something new in R without having any coding background. And this is possible because of all of the amazing R resources and the incredibly supportive community that I was able to go from scooping water samples to getting to code with my cats all day. So I would love to connect with you. I love to talk about cats, R, data, whatever. I have my slides, the source code for WaCSE, and then at the footer is also the app if you want to try it yourself. So I will also post this in the Slack channel. Thank you.